class, remember we have two types of Cartesian, which is rectangle and non-rectangle. So how about if we have the solid non-rectangle solid? Okay, so you have three types: type 1, type 2, type 3. Okay, three types of region. So if we choose type 1, we will integrate over xy solid. If we choose type 2, we will integrate over xz solid. And if we choose type 3, we will integrate over yz solid. So let us see how. So class, if we talk about type 1, meaning that the region will be lies between x and y. Okay. So meaning that, you see, type 1, you have to get the limit, okay, for z. Okay, equation z between k1 xy to k2 xy. And how about xy? Okay, xy, the limit for xy is same like double integral. So you will go back to your double integral. Okay, so this one, you refer xy region. Okay, and then you remember that you have what? Dx dy and dy dx. So you can choose the type. If you choose type 1, meaning that the region lies on xy plane. Okay, region lies on xy plane. Okay, and then this one is dA. So dA can be dx dy or dy dx. Okay, if we choose type 2. Okay, type 2, integrating over xz solid. Okay, meaning that the region will be lies on the xz solid. So, what is the limit of integration? You see here, region lies on xz solid, okay, or xz plane. So, this one, dA, okay, so dA can be dx dz or dz dx. Okay, and then type 3. Type 3 region. Okay, type 3. Integrating over yz solid. So, the region will be lies on the yz solid. Region lies on yz solid or yz plane. So, what we can do is, we have dA here. So, dA can be dy dz or dz dy. Okay, so how about inside? Inside is dx. Okay, for type 1, inside is dz. Type 2, inside is y. Type 3, inside is z. So, you can remember this one. And then I conclude, this dv become dz dA. Okay, so dz dx dy or dz dy dx. So this dv become dy dA. So you can choose whether dy dz dx or dy dx dz. Okay, next, this dv become dx dA. So dx dy dz or dx dz dy. So we look at example. Example 1. Limit are not directly given. So what you should do is you have to find the limit of integration. Let G be the wedge in the first octant. Okay, you have to know where is the first octant. Cut from the cylindrical. So we have cylindrical. Okay, so you have to go back to your chapter 1, how to sketch cylindrical. Okay, you have cylindrical solid, y squared plus z squared equal to 1 by the plane. Okay, you have plane. What plane? Y equal to x. And x equal to 0. You see, let G be the wedge in the first octant cut from the cylindrical and by the plane y equal to x and x equal to 0. So G is the solid. Okay, G is the solid, or we call 3D. Okay, so you should know how to sketch 3D and how to sketch G. And then the question given is Z. So Z dV. So this one we will choose, okay, the order later. Okay, you see the step. First you have to sketch the solid, which is G. And then you have to check the solid, okay, which lies on which region. Then you have to sketch the region. Okay, what region? Area. You remember before this we learned about double integral. So this one is double integral. You see, double integral dA. And then you should choose your order of integration. Okay, and then for dA, what dA? dA is from double integral. And then what you should do is find the limit for dA and then limit for third integral. And then you solve as usual. So, can you try what we get? Can you try to sketch the solid? Okay, class. Let's say we sketch as using GeoGebra. Okay. Okay, so we have cylinder, and then we have y equal to x, and then we have x equal to 0. Okay, so you see, we have this region. So where is G? Okay, we read the question. Question said G be the wedge in the first octant. So if we talk about first octant, so where is the first octant? So the first octant is at positive z, positive y, and positive x. So here, this is the region. Okay, so how to get the answer? If you want to sketch manually, yes, you can. Let us see. Okay, class. Let us sketch the solid. Okay, first we have y squared plus z squared, okay, equal to 1. Okay, we know that if we have two variables, so this one is cylinder. Alright, so we have to project to x-axis because x is missing. Project to x. Okay, so let us try to sketch. So we have z and then y, and then the radius is 1. So the question said first octant. First octant meaning that all positive. So I just sketch here. Okay, now we want to project to x-axis. Let's say I project here. So you will get something like this, right? Okay, then we have what? Y equal to x. Y equal to x. Okay, let us see how to sketch y equal to x. So this is y and then x. So when y, okay, we know that y equal to 1. Okay, when y equal to 1, so we get x equal to 1. So we get here. So this is y equal to x, what we get straight. Okay, so and then first octant is all positive. Okay, so how to sketch 3D? Okay, so if we project to Z, so we have 3D, Z, Y, and then X. So how? We have Y, okay, this is 1, this is 1. So if we sketch, we will get this, right? Okay. And then we can project to, let's say I project here. So I get this 3D. Okay, so if I sketch here, okay, so you imagine one is here, okay, so this is the line, and then I sketch the 3D here. Okay, let's say I project like this. Okay, you see I cut the cylinder like this. Okay, so if I cut the cylinder, what we can see? Okay, so you can take this point. How to cut the cylinder, class? Let's say I use the blue color. Okay, how to cut? You take this and then this one. So you cut like this. See? You follow the same line for cylinder. Okay? So you get this. And then last we have x equal to 0. Okay, if we sketch x equal to 0, what we get? Okay, we get x equal to 0 is here. Okay, and then remember that this is first octant, so all positive, right? And then how to get x equal to 0? So we project to z, and then we project to y. So we get this. So this is x equal to 0. So how to cut? Okay, so I sketch again here. Okay, so you imagine that I cut here. Okay, so we will get the orange color, this one. Okay. Okay, now class, if we see, we will get this shape. See? You will get like this. Okay. And then like this. So this is G, the solid. So you have to integrate this. Okay, let us see how to integrate. Okay, let's say we choose type 1. So we have dz, dA. Okay, now we will choose what is our dA, okay? So first we have the region. Okay, what we should do, dA is XY plane, right? Okay, so what you should do, you have to do like this. Okay, you sketch. Okay, sketch XY plane. Okay, so you sketch, you will get this. Y equal to X. And then 1, you get this. Okay, you sketch XY plane. Then you see y, and then you have y equal to x. So you get this. Okay, so you have to know what is integration. Okay, let's say I use type 2, okay, dx dy. So dx dy. So you refer again double integral. What you get is, okay, if y is what? 0 to 1. And then x, okay, this is what? X equal to 0. And then this is x equal to y. So from 0 to 1, 0 to y. You see? 0 to 1, 0 to y. And then this is dx dy. And then how about z? Okay, how about z? Okay, you see this? Let's say I color here. This is what? This one is z equal to 0. Okay? And then how about this? I color again here. Do you still remember? This is come from cylinder. Okay? Cylinder. Okay, what is that? Y squared plus z squared equal to 1. So you have to change into z. Z equal to what? Okay, let us see. Z squared equal to 1 minus y squared. And then z equal to plus minus 1 minus y squared. And then z equal to positive. Okay, this one is positive because this one is first octant. That's why positive. So integration is between 0 to square root 1 minus y squared. Let us see the answer. Integration for z is start from 0 until square root 1 minus y squared. And then we integrate as usual. Okay, integrate z. Okay, first integrate z, we get z squared over 2. Okay, z squared over 2. And then we substitute the value square root 1 minus y squared and then substitute 0. So we will get this 1 over 2, 1 minus y squared. And then we integrate with respect to x. Okay, so 1 minus y, 1 over 2. So 1 over 2, 1 minus y squared is constant. So what we get is 1 over 2, integrate from 0 to 1, 1 minus y squared, x. Okay, then we substitute what is x, and then 0. So we get 1 over 2, y minus y cubed. And then we integrate this. We will get 1 over 2, y squared divided by 2 and then minus y power of 4 divided by 4 from 0 to 1. And then we substitute the value 1 over 2. We will get 1 over 2 minus 1 over 4 and then minus 0, right? So 1 over 2, 1 over 4. So the answer is 1 over 8. So please show this step. Alright, so the answer is 1 over 8. Okay, let's say class, if you want to choose, for example, type 3. Okay, what is type 3? dx, dA. So if you choose type 3, you will get dx, dy, dz or dx, dz, dy. Okay, let's say you choose dy, dz here. So you see, what you should do is, this one is double integral, okay, yz. So you have to sketch z and y. You see, z and y. So you get this. Okay, we go back to our 3D. You see z and y, you get this. Alright, half circle, 1 over 4 circle. Okay, so what is the limit for z? 0 to 1. Okay, and then how about dy? Okay, dy. Okay, this is y equal to 0 until y equal to what? Y equal to, okay, positive. This is positive y. So square root 1 minus z square. So you see 0 to square root 1 minus z square. And then how about dx? Okay, so we go back to 3D. You see x. Okay, x we start from, okay, this is what? X equal to 0 until x equal to y. So the limit is 0 to y. So this is how to answer the question. And then you can integrate as usual. Okay, you can integrate z dx dy dz. You will get same answer, which is 1 over 8. Alright, so you all can try.